Hello, my name's Lucas and today we're going to be looking at the nth term of a linear sequence. Hope you're well and let's get cracking. Okay, so what is a linear sequence? What is a sequence? So a sequence is just a list of numbers. It might be finite, so it might stop at some point, or it might go on forever, it might be infinite. And a linear sequence is a list of numbers that goes up or down by the same number every time. So for example, 4, 7, 10, 13, 16 keeps going. That's a linear sequence because it goes up in threes each time. 100, 90, 80, 70 keeps going. That's also a linear sequence because it goes down in tens each time. 1, 1, 2, 3, 5, 8. That's not linear because the differences changes. Yeah, so between 1 and 1 there's no change. Then it's add 1, then it's add 1 again, then it's add 2, then it's add 3. Yeah, so that is, we'll just name it just so you've seen it and heard of it because it might come up in future videos. That is what's called a Fibonacci. Do I feel like this? I feel like there's only one N in Fibonacci, so let's call it a Fibonacci sequence. And the rule of that is you start off with two ones and then the next number you add the previous two. So 1 plus 1 is 2, then 1 plus 2 is 3, and you keep going like that. But it's certainly not linear. Okay, so just a few practice questions then. So we want to know if these sequences are linear or not, and if they are linear, what is the rule going from one term to the next? Feel free to have a go, pause the video, otherwise we shall do it together. So number one, we've got 8, 13, 18, 23, 28. Well, that is linear because we add 5 every time. So the rule is add 5. Number two, we've got 2, minus 4, minus 5, minus 7, minus 8. Well, that's not linear because we're taking away 2, then 1, then 2, then 1. So that is not linear. The next one, we've got 3, minus 1, minus 5, minus 9, minus 13. Well, that is definitely linear. We are taking away 5 each time, so that is good. That is minus 5. And then number 4, we've got 12, 19, 26, 33, 41. Well, it was looking good right until the last one, because all of these are add 7. So it looks like we've got a good pattern, but then the last one is add 8. So it's not quite linear just because of the last one not fitting the pattern. Okay, so now we know what a linear sequence is, what they look like. We need to figure out how to write an expression for the nth term. Now the nth term is just saying any term. You know, if you want the third term, you'd put in 3 instead of n. If you wanted the ninth term, you'd put in 9 instead of n. So we want to know how to get that expression. So the first thing you do is find out how many it's going up or down by. So if it's going up, it's going to be a positive number. If it's going down, it's going to be a negative number. Then what you do is you look at the first term and think, right, well, for that first term, n is 1. So you substitute n is 1 and then think, well, how much more do I need to add or take away to get to that first term? So it'll be a bit easier to do it with an example. So here we go. We've got 4, 7, 10, 13, 16. This goes up in threes. So your expression is going to have 3n in it. Then we're going to either add or take away a number to that. So we look at n is 1. Well, n is 1. 3n is just 3 times 1, which is 3. And this is our first term here. So to get from 3 to 4, we just add 1. So that's what gives us our 3n plus 1. And that should work for all of them. So we could even try, let's try the second term. So for the second term, let's use a different colour. We've got n is 2. And we should end up with 7. So 3, oops, we use a proper pen. So 3 times 2 plus 1. 3 times 2 is 6. And 6 plus 1 is 7. So it works. It should work for all of these. Okay, so let's just have a go at a few examples. Feel free to pause the video and have a crack at these. Otherwise, we'll do them together. Okay, so the first one then. So what are we going up in each time? Well, it looks like it's added 8. So we know our expression is going to have 8n in it. Now for the first term we've got 7. Now when n is 1, this 8n is just going to become 8. So how do we get from 8 to 7? Well, we just take away 1. And that's our nth term for that sequence. The next one, we seem to be going down in tens. So because it's going down, there's going to be a minus, and it's minus 10n. Now how do we get to 41? Now if n is 1, this is going to be minus 10. And to get from minus 10 to 41, if you think about a number line, if you're on minus 10, it's going to take you 10 to get to 0, and then another 41 to get to 41. So altogether, you would have to add 51. And that is that one. And then finally, this one, we're going from minus 24 to minus 13 to minus 2. So this is going up in 11s, so it's going to be 11n. And then for n is 1, that's going to be 11. So how do I get from 11 to minus 24? Well, it's, again, think about my number line. It's going to take me 11 to get to 0, and then another 24 to get to minus 24. So this is going to be minus 35 altogether. Okay, and those are the nth terms of those sequences. Okay, so let's try a worded example. So here are some patterns made up of dots, and we want to draw pattern number 4 to start with. So if we just look at these dots, let's see what the pattern is. We've got rectangles, and if we just start with the top, we've got, for the first pattern, 1, 2, 3 across the top. For the second pattern, we've got 1, 2, 3, 4, and for the third pattern, we've got 1, 2, 3, 4, 5. So for our pattern number 4, the next pattern, we should have 6. So this is part A. So it's 1, 2, 3, 4, 5, 6. How many does it go down? Well, there's 4 on pattern number 1, 5 on number 2, 6 on number 3, so it should be 7. So 1, 2, 3, 4, 5, 6, 7. And then I'll just continue my thing. 1, 2, 3, 4, 5, 6, 7. So that is my pattern number 4. Okay, part B, we want to write down an expression for the number of dots in the nth pattern. Okay, well, let's start counting these dots then. So in number 1, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 dots in that one. For the next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we're starting to see a pattern. So I'm hoping there's going to be 22 in my number 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Lovely. Great. So we want to write an expression for the number of dots in the pattern. So it goes up in 4s. So it's going to be 4n. And then for the first pattern, we need to go from 4 to 10. So we add 6. Great, and then part C is how many dots would the 100th pattern have? Well, we just put 100 into our formula. So this is 4 times 100 plus 6, which is 400 plus 6, which is 406. And that's our answer. Okay, so I hope you found this useful, the nth term of a linear sequence. We'll be doing another video soon about deciding whether a term is or is not in a sequence. But otherwise, please like and subscribe this video, and I'll see you soon for some more maths videos.